Okay, I'm going to take you through vector equation of a line and intersection of two lines, and then an application. So if we've got 2 points, A and B, at 2, 4, we know how to find the equation of this line using slope-intercept form, y equals mx plus c, where c is the y-intercept, m is the slope. So first we'd find the slope between the points, and then use one of the points to plug it back in and get the y-intercept. Vector equation is a bit different, but it kind of looks the same. R equals A plus TB, where R is like the y equals, but it's a vector. And then A is like the C, but it's also a vector. And the B is like the slope, which is another vector. And T is like X. T is called a parameter. So A is a position vector. B is a direction vector. That's parallel to the line. You can think of it as the slope vector. And then, like I said, T is the thing that can change. So T is like part of the equation, sort of like, the equation of this line would be negative 1/4 x plus 4.5, where, x and y have to be in this equation. They are the things that can change. So when you have a vector equation of a line, you're going to have R equals some vector here times T plus another vector here, where this is B, the B vector, and this is the A vector. You can also switch it around, just like you can switch this equation around and say y equals 4.5 plus negative 1/4 x. The order doesn't matter, so just watch out for that. So here's vector equation 2, 4. That's the A vector. And then, like I said, the parameter can go in the front or the back. Typically, it's in the front, and that's a scalar multiple. It gets multiplied by both of these. Okay, and we can check to make sure, like, this is the actual equation by, if we plug in values. So, like I said, t could be anything. So if t is 1, we plug in into the equation. So we have 2, 4 plus 1 times 4 times negative 1. So we're multiplying these two together and then adding. So 2 plus 4 times 1 is 6, and 4 plus 1 times negative 1 is negative 1, and that's where we get the 3. And we know this point is on the line. It's right here, 6, 3. We can do 10, 2. When t equals 2, so change this 1 to a 2, and now all of a sudden we have 2 plus 8, which is 10, and 4 plus negative 2, which is positive 2. And then we have another point that's on the line. Oh, sorry, this one was not 6, 3. This was 4, 2, 2, 4. This one's 6, 3. And we can see 10, 2 is also right there. So you can see it's forming a line. I could also do t equals 3, t equals 0, t equals anything, and see that we're getting a straight line here. But it's a vector equation of a line. So think of, like, in geometry class, we would say parallel. In order for two lines to be parallel, all that needs to be true is they don't need to cross. But vector equations don't work like that, because if you're in 3 dimensions and you're holding up your pencil in midair, you can hold up another pencil underneath it and they won't cross, but they're not parallel. So, think of planes or helicopters flying over each other. They don't have to be parallel. That's not the only condition for them to not cross, right? One could be above the other. So we have to be thinking like that when we do vector equations. So here's an example, a pretty basic example. I've already got the answer down here. So a line passes through the point A. This will be our position vector. So that's this part that I plugged in there. And then I just wrote it as a column vector. And the direction, it tells us the direction, -3, 2, 1. So that goes in for B. And it looks a bit complicated, but it's pretty easy to just plug those values in. You can also write, you can write this in unit vector form: 2i plus 7j plus 10k plus -3ti, and you can keep going, plus 2tj plus tk, because if you multiply this t by everything. However, you probably won't see it like this in IB, but I'm just making you aware that that's how it works. So a little bit harder one. If we know the line passes through 2 points, and we need the vector equation of a line, the first part, sorry about that. The first part, vector A, can be either one of these points. It doesn't matter. So you can choose -4, 6, 9, and then do plus the parameter. But now B has to be a direction vector. So if it passes through these 2 points, it doesn't actually matter if you find GH or HG. It doesn't matter, even based on the point you pick. So if we find, I'm just going to find the vector GH and say that's going to be my direction vector. So I'm going to do -5 minus -4, 1 minus 6, and 2 minus 9. That's how. If you want the vector GH, you got to do H minus G. So then this comes out to be, that's a plus. So that's -1, -5, -7. And so that goes in here. -1, -5, -7. And I should put R equals, and there's my vector equation of the line. Like I said, it doesn't matter which point you pick. You can say, actually, my position vector is going to be H and plus T, and I'm going to use the same direction vector I just had. You can plug in values for T and check that you're going to get the same points all along these lines. You can even do it a third way and find HG. So just keep that in mind. Typically, yeah, it really doesn't matter. Typically, I just choose the first point to be my direction vector, and then just find GH in the order of the points that I'm given. And the examiner should be able to figure out what you did if you did it some other way. So then, how are we going to use these skills? We're going to take, we're really, in problems you're going to be given, we're going to want to see if lines cross. So the lines could intersect. This is probably the most typical thing they'll give you because they want you to find the actual intersection point. Lines could be parallel. They could be coincident. That means they're basically the same line. They're overlapping. And then skew is this case I was talking about before. They're not parallel, but they don't cross. So it could be like planes flying over the top of each other. So you're going to be given problems like this where they give you vector equations of lines. Maybe they call them L1, L2 sometimes. And if there's 2 lines, they give you different variables for the parameters, S and T typically. So we just have to know that this vector and this vector are telling us the direction, and the first 2 vectors are telling us the position. So like think we've got some position and we're going in some direction. It's the same way we've been thinking about vectors. So show that the lines intersect. So we're being told they do intersect. We need to find the coordinates of the point. So if this is true, there should be a value of T and S that would make this true. That would make the equations equal to each other. So we need to find those values of T and S. And the way we do that is we set them equal to each other. Nothing's really fancy is happening yet. But now, these equations, we're setting up a system of equations, and I'm just taking 3 plus s equals 6. That came from 3 plus s times 1 equals 6 plus t times 0. So I could have said 3 plus s equals 6 plus 0t, but 0t is just 0. And then the second equation, let's call this equation 1, equation 2, equation 3. Second equation is 0 plus s times 1, so just s, equals 2 plus t times 4, so 4t. And then the third one, negative 1 plus s times 1, so negative 1 plus s, equals 0 plus 8 times t. So that's how you get those equations. It's pretty easy. But then we should be able to, let's get rid of this 0t, we don't need that. We should be able to solve for s and t so very easily. Sometimes they make them a little bit harder, but right here, I mean, you can obviously tell s has to be 3 because 3 plus what equals 6. And now that I know s, I can plug it into the second equation or the third equation and get t. So I'm going to plug it into the second one and get 2 plus 4t, and then I can subtract 2, and I see that t is equal to 1/4. Okay, so those are my values for s and t, and really you only need one of them. And we can show why that's the case. To find the coordinates of the point, all you have to do is now go back and plug your s or t values back into the equations. So if I plug in s equals 3 into this equation, what point do I get? I get 3 plus, and I'm plugging in 3 here. So 3 times 1. So that's 6 for my x coordinate. Then I do 0 plus 3 times 1 is 3. So that's my x, that's my y, and this is my z. Then I do negative 1 plus 3 times 1. So negative 1 plus 3 is 2. So that's the coordinates of the point of intersection, 6, 3, 2. We could write it as an ordered pair. And now, like I said, it doesn't matter which one of these you find and choose, because if I plug in 1/4 into this part, I'm just going to get the same point. So 6 plus 1/4 times 0, 1/4 times 0 is just 6. Then for the y coordinate, I do 2 plus t times 4, 2 plus 1/4 times 4, which is 1. So I get 3. And then z, I do 0 plus 1/4 times 8, which is 2. And so you can see we get the same point either way. All right, so now an application of all of this. We're given position of a boat, A, t hours after it leaves the harbor, is given by this equation. R1 equals t times 30, the vector 30, 15. And notice we're missing something. This vector, we really should be thinking of it like this. 0, 0 is the position vector, and then 30, 15 is the direction vector. So really should think of it like this. The second boat has a position vector 55 and direction 10, 10. Okay, so we've got two different parameters. I could call one of them s and the other one t. It doesn't matter. So typical question, how far apart are the boats at the time the first boat leaves the harbor? So this would be the time when t equals 0. So we just plug in 0 for t. R1, it just wipes everything out. But R2, if I plug in 0 for t, it wipes out the direction vector, and we're left with 50 and 5. So then to find the distance, we use the magnitude formula. And I mean, really, we would have to, if this was a value, we would have to subtract first, right? Because distance, we subtract. So 50 minus 0 is 50. 5 minus 0 is 5. And then we take the magnitude, and we get about 50.2. kilometers. So if this R1 equation had something else in it, we'd have to subtract whatever that position was. So that's important to keep in mind. How fast is each boat traveling after 2 hours? So speed equals the absolute value of velocity, something that you should memorize. And the direction vectors represent the velocity vectors. So if you want to know, if you're asked about speed or velocity with vectors, you gotta think of these two vectors right here. So all we need to do is plug in 2 for t first, because it says after 2 hours. So for boat A, I'm plugging in 2 for t, so we get 60, 30, and then you find the magnitude. And for boat B, we do the same thing. Plug in 2 for t, and you've got a little extra step, because 2 times 10 is 20, plus 50 is 70, and then again on the bottom. And then do the magnitude, and round to 3 sig figs. So there we have the speed of the boats. Okay, and then last part, are the boats in danger of colliding? Or basically, if they do collide, find the point when they're going to collide. So in order for them to collide, this is like the one we did on the previous slide, we need to figure out what that parameter would be. And so we're setting these two equations equal to each other. But notice what I've done here. I did 30t equals 50 plus 10t. So just like we did on the previous, multiply the parameter through and set them equal to each other. Set up system of equations. So this equation only has one variable, so we can solve it easily. Subtract 10 on both sides. We could set up another equation using the bottom half, so t times 15 equals 5 plus t times 10, just like that. And we'd see t equals 1. Now, the key on this problem is that these values are not the same. And so this would mean they do not collide. And so that's how you would solve this problem. All right, so you can let me know if you have any questions. You can also check out Cognity and go try the problems on quizzes.